About 48 hours ago, the Storm Prediction Center had the area outlooked for a moderate risk for severe thunderstorms. The outlook area covered much of the mid-Mississippi and lower Ohio Valley regions. The expectation was we could see supercell thunderstorms produce large hail, damaging winds, and strong tornadoes by Monday afternoon into Monday night. Well, the high end severe weather did not quite materialize. Plenty of severe weather reports across much of the region Monday afternoon, Monday night, even earlier in the day with some elevated storms, but not much in the way of significant severe and tornadoes. I've had some folks reach out to me. They expressed interest in my thoughts as to why the system fell short. So I'll share some of my thoughts and look at parameters I tend to rely on ahead of high end severe weather and tornado events across our region. And again, just my thoughts and opinions based on my experience over the years. So, one of the first things that came to mind was, what did the vertical speed shear look like? Vertical speed shear being winds increasing in speed with height. So, I took a look at three major events across our area over the past 10 years or so. High end tornado events, Mayfield, Perryville, Crossville back in 2017, and recently the March 14, 2025 tornadoes in southeast Missouri. Comparing the uh, shear, actually the wind speed at 500 millibars and the overall 500 millibar pattern with those events to what I saw on the mesoanalysis from the Storm Prediction Center Monday and Monday night. So, first up is the March 14, 2025 event, where we had several EF3 tornadoes that evening across southeast Missouri. This is the mesoanalysis 500 millibar plot from the Storm Prediction Center that evening, showing a deep closed low over southwestern Iowa and strong mid-level winds coming up from northern Texas across Oklahoma, Arkansas, and then eventually to the Mississippi River. Winds on the order of 75 to 85 knots, and very close to our region, indicated by the yellow star there, right in the middle of the map. So, pretty strong winds with this system, a very dynamic system back on March 14th of 2025. Next up, an event we're all familiar with, the Quad State / Mayfield tornado, December 10, 2021, high end DF4 tornado event. 500 millibars again from the mesoanalysis from the Storm Prediction Center, showing a broad but deep mid-level trough from the Dakotas down across the central high plains. And in advance of the trough, we have a nice 75 to 85 knot wind max shooting up out of Arkansas across southeast Missouri, central sections of Illinois and Indiana. Um, Again, we're in very close proximity to that wind max of 75 to 85 knots, and we're also positioned nicely to the right rear quadrant of that upper jet, which is a region where you have your greatest forcing for ascent. And the third event that we're going to take a look at and eventually compare it to what we saw Monday and Monday night is the Perryville EF4 tornado event, almost EF5 tornado event that happened back in 2017, February 28th. The overall 500 millibar pattern that evening looked a lot like the Mayfield event. We had a deep trough from the Dakotas down across the high plains, and you had your mid-level maximum winds coming up out of the southern plains across the mid-Mississippi Valley region on the order of 75 to 85 knots, once again increasing through the evening. And we were positioned in very close proximity to the upper jet and in that right rear quadrant region. So now let's take a look at the SPC mesoanalysis 500 millibars for Monday evening. And in contrast to the other systems, this particular pattern, not as volatile, not as intense looking to me as the others. The flow a little bit flatter from southwest to northeast. The short wave lifting from the plains across the upper Midwest with a negative tilt aspect. And you can see the maximum jet winds from western Illinois down across northern and central Missouri back into northern Oklahoma. So across our area, displaced a little farther to the south and east now, our 500 millibar winds were only on the order of 45 to 50 knots. So considerably lower than the three high-end tornadic events that I depicted just a short time ago. So up to this point, We've been looking at plan view maps, 500 millibars. Let's switch gears and look at the vertical wind profile from the Paducah radar Monday afternoon between 3 and 4 o'clock. And what we see in the vertical is a low level jet, a little bit of turning of the wind from 0 to 3 kilometers, 45 to 50 knots or so, going higher up to about 18,000 feet, 6 kilometers or so, and up from there, winds are on the order of maybe 50 to 60 knots. So overall, maybe a 5 to possibly 10 knot increase in the wind speed from what we see below 3 kilometers. That's not terribly impressive when it comes to vertical speed shear. The high-end tornadic events that I showed you just a few slides ago, the values were almost double in some cases, the magnitude of the upper level winds versus the lower level winds. So as most of you probably know, but I'll go ahead and bring it up anyway, why is vertical speed shear important? Well, the speed shear helps vent the storm's rain-cooled downdraft region away from the warm, buoyant inflow region. And the map to the right from NOAA depicts this very well. It's important to maintain good balance and have adequate speed shear, working to prevent a self-destructing process with the severe thunderstorm. You're carrying the precipitation downwind and preventing it from falling back into the updraft region. So the NOAA graph and image here shows the elongating wind barbs with height, showing your vertical speed shear. You see the tilting storm carrying the precipitation away from the storm inflow region and the updraft region there. Nice tilt from the cloud base or wall cloud region up through the mesocyclone to anvil level. Another parameter that I like to look at is 0 to 8 kilometer shear. And this is something that I shared with my colleagues. It's pretty standard to look at 0 to 6 kilometer shear, 0 to 3 if you're thinking QLCS, effective bulk shear, or BWD, bulk wind difference. But I like the 0 to 8 kilometer shear. I think SPC site says 50 knots or greater is what you're looking for. I'm going to show how that looks to be true in the next two images here, comparing what SPC had on their mesoanalysis Monday evening with what we saw Mayfield and then back March 14, 2025. So 45 to maybe 50 knots of 0 to 8 kilometer shear according to SPC's mesoanalysis Monday evening. Contrast that with Mayfield. We were looking at 75 to as much as 85 knots of 0 to 8 kilometer shear. And we see something similar comparing March 14, 2025 to Monday and Monday night. Again, over our area a couple of days ago, 45 to maybe 50 knots. You compare that to a little over a year ago across southeast Missouri, 90 to nearly 100 knots of 0 to 8 kilometer shear. And we had 5 or 6 EF3 tornadoes, if I remember right, over southeast Missouri in an extreme high shear environment. The instability wasn't quite as high, but easily overcame that with the degree of shear across much of the lower and middle Mississippi Valley. So we're going to switch gears one more time and look at something else. I was trying to think what else besides perhaps this wind shear issue could be holding thunderstorm development back from that explosive development turning rapidly severe over the region. Why were storms holding back to the north and west and not developing over us? And I remember watching a storm chaser in the region, and they did bring up, they wondered, could temperatures aloft be a little bit too warm? Could there be an element of capping? So I decided to look at 700 millibar upper air from that evening at 7 o'clock, and temperatures were 9 to 10 degrees Celsius, which for late April climatologically, that's a little high. Like to see those values a little bit lower. So there may have been somewhat of a weak cap across the area as well. So continuing on from the idea that temperatures may have been a little bit too warm at 700 millibars, that's just one layer, but perhaps there was a slight cap in the late day and evening hours. We had a wave move across the area Monday morning, and the wave was accompanied by elevated severe thunderstorms. They were hail producers. That wave departed off to the north and east by late morning. Skies started to clear out. through the afternoon, we destabilized. Temperatures got into the lower 80s. Dew points were upper 60s. But we didn't really have another wave waiting in the wings to kick things off. We didn't have any surface convergence. It was just southwesterly, low level flow. Really no forcing mechanisms in the afternoon and early evening. The instability alone was not enough. The low level shear, great that it was in place, but it was just going to sit idle until storms got going. You'd see these little showers pop up on radar in southern Illinois, West Kentucky, southeast Missouri. They'd take on the kidney bean, banana shape, real small. You get a lightning strike, they'd go up. 20 minutes later, they were back down. They just couldn't get going. So I think that had a lot to do with it, and we had to wait on the next system aloft and the boundary to come in from the west to get things going. And by then, the other parameters were not as favorable. So it didn't all come together, is the bottom line. So here are your severe weather reports. Not a lot over West Kentucky, Southern Illinois, and Southeast Missouri, as you can see. I did outline in blue and orange where the mid and upper level jet positions were that evening, and we were just displaced too far to the south and east, in my opinion. We needed to be closer. You can see there were more reports along the I-44 corridor there in Missouri, and that makes sense. So if you've hung in there this long, I sure do appreciate it. I'm going to go ahead and wrap it up. Just some observations from a retired National Weather Service employee. Worked a few high-end events over my career, and definitely felt the sting of a bust. This wasn't a total bust. I mean, we had severe weather reports, but just not the high-end events. And for me, it goes back to vertical speed shear. Where was the upper level jet with respect to us geographically? Was it in phase? Was it lined up with the other favorable parameters like the low level shear and the brood instability? For Monday and Monday night, it really wasn't. It was a little out of phase for us, and I think that held things back. But the good thing is bust or whatever you want to call it means no significant damage. Everybody's okay. And in the end, that's what matters. You take an event like this and you learn from it and you move on. Most of them we do okay on, but you're going to have one like this every once in a while. So I hope you found this informative, and I appreciate you watching, and I hope you have a great rest of your evening. Take care.